Hello everyone. In the last lecture, we discussed why we need limits. Today we discuss exactly what is the limit of a function. We will understand the basic definition and we'll look at some interesting examples to make it clear. Let's start with the basic definition. Suppose function is defined for all values of x in some open interval about x naught, except possibly at x naught itself. Okay, that is, function may be defined at x naught, may not be defined at x naught. Look at this graph. Function is undefined at x naught, but it is well defined about x naught. So if the value of function fx gets arbitrarily close to L, some fixed number, as x gets sufficiently close to x naught, then we say L is the limit of this function as x approaches to x naught. Mathematically, we write limit x tending to x naught fx equal to L. In other words, we say fx approaches to L as x approaches to x naught. Here L is the single finite value. Okay, so from graph also you can see as x approaches to x naught from left, function approaches to value L from left. X approaches to x naught from right, function also approaches to value L. Okay, now limit and function value. As we know that limit depends on how function behaves near the point A, not exactly at itself. Okay, function may be defined at A, may not be defined at A, but limit tells about the nearby behavior of the function. Okay, let's compare the limit value and function value. Okay, so in this graph, see, function is undefined at 1. Function is undefined at 1, but limit value is 2. How? As x approaches to 1 from left or right, the function approaches to value 2. Okay, so limit value is 2. Function is undefined, but limit value is 2 here. Hence we say function might be undefined at some point, but limit still may exist. In second graph, function is defined at 1. See, function is defined at 1 and value of function is 1. Okay. Now what about limit value? See, as x approaches to 1 from left, function approaches to value 2. X approaches to 1 from right, function approaches from right to value 2. So limit value is 2 here. So here both function value and limit value exist, but both are different. In the third graph you see both function value and limit value exist and are equal at x equal to 1. Function value is 2. See here, also limit value is also 2. Okay, so this is the case when we say the function is continuous at the point x equal to 1. So this function is continuous at x equal to 1. Now let's take our first example. Function is defined as f of x equal to 0 for x less than 0. Function value is 1 if x is greater than or equal to 0. See the graph of this function. Okay. So what happens at x equal to 0? So here you see function jumps 1 unit at x equal to 0. So this function is called unit step function. Now what about limit? As x approaches to 0 from left, okay, x approaches to 0 from left, what is the behavior of function? Function also approaches to 0, okay, from left. From left means 0 minus, we are writing here, you see 0 minus means x approaches to 0 from left. X tending to 0 plus means x tending to 0 from right. So if x tending to 0 from right, then function also approaches to value 1 from right. So we see that as x approaches from left, function approaches to value 0. X approaches to 0 from right, function value approaches to 1. So function is not approaching a single finite value L as x tending to 0. So we say function has no limit as x tending to 0, or the limit does not exist at x equal to 0. Next, let's see another interesting example. Here function is defined as gx equal to 1 by x for x not equal to 0, and gx is 0 for x equal to 0. This function is called reciprocal function. Graph of this function you can see here. Okay, so now question is, what is the behavior of the function as x tending to 0? So if x tending to 0 from left, then we see that function becomes very large negatively, means tends to minus infinity. As x approaches to 0 from right, function becomes very large positively, means it tends to plus infinity. Okay, so since the left hand and right hand limits are going to approach plus infinity or minus infinity as x tending to 0, means function is not approaching a single finite value L. So we can say function has no limit, that is limit does not exist for the given function. Now consider the function which is defined as h of x is 0 for x less than equal to 0, and it is sine 1 by x for x greater than 0. This function is called oscillating function. See the graph of this function. You can see the graph here. This graph shows very dense oscillations near 0. Okay, so as x approaches to 0 from left, okay, function keeps oscillating between -1 and 1. It never have a single value. Okay, if x approaches from right, again function oscillates between -1 and 1. Okay, so function is not approaching a single finite value as extending to 0 from both sides. So we say limit does not exist. Function has no limit as extending to 0. Now example is, explain why the following limit does not exist. Limit is limit extending to 0 x by mod x. So here function is x by mod x. And this function can be written as 1 if x is greater than equal to 0, and value of function is -1 if x less than 0. How we are getting it? By using the definition of modulus function. This is mod x is x if x is greater than or equal to 0, and it is minus x if x less than 0. So if x is positive, so we will have function x by x means 1. If x is negative, then x by minus x means -1. If you draw the graph of this function, see, so at 0, function has jump, x greater than 0, then it is 1, x less than 0, it is -1. So this is a graph of function. So this graph also has jump at 0. So as x approaches to 0 from left, function approaches to -1. So graphically, you see that x approaches to 0 from left, function approaches to value -1. Okay. As x approaches to 0 from right, okay, function approaches to the value 1. So function is not approaching a single finite value L as extending to 0 from both sides. It approaching 1 and -1, not a single finite value, so limit does not exist. So in this example, function value is given at 1, it is 7. Question is, can we say anything about limit extending to 1 fx? And the second question is, if the limit exists, must it equal 7? So, you know that this is a common confusion among students. You see that function is well defined at 1. So, f1 is 7. Does that automatically mean the limit is 1? So, answer is no. The limit only depends on how function behaves near x equal to 1, not exactly at 1. Okay, so function value and this limit may be equal or may be different. So limit does not depend on function value. That's all for today's lecture on what is limit of a function. I hope this video made the concept simple and visual. If you liked it, please like, share and subscribe to my channel for more related videos that I will upload soon. Thank you.